In this example, we're going to use the elimination method to find the solutions to the system. And this is a little different because we're kind of used to maybe linear equations. If we see two variables, we're used to like the two linear equations and two variables. But this has a square terms, but that's okay because we know how to solve those equations as well. Recall the method will never change, just the problems do. So the method for elimination just says that you need to pick a variable, and then after you pick a variable to eliminate, you will eliminate that variable by making sure the coefficient in front of that variable are the same but opposite signs. So if we want to pick a variable to eliminate, I would advise us to pick y. And the reason why I pick y to eliminate, or the y squared term, is because I already see that they are opposite signs, and I would just need to make sure that their coefficients are the same but opposite sign. And notice even the coefficients are the same, like they're exactly the same except opposite signs. So I'm going to go ahead and pick y to eliminate. Or we could say y squared term, however you want to say it. And the second thing would be, once you do that, we would just want to verify that they have the same coefficient and opposite signs. Okay, and we can see that that is actually done, right? They are positive y squared and negative y squared. So when you realize that you already have that, it's an actual, you just kind of just go straight to elimination. So next I would go ahead and take the system and just start solving. So of how we know. So if we have x squared plus y squared equals 6, and x squared minus y squared equals 2, if I go ahead and just add these two together, x squared plus x squared is 2x squared, plus y squared minus y squared, those cancel just like we wanted, and that's equal to 8. And then if I divide each side by 2, I get x squared equal to 4, and therefore x will be equal to plus or minus 2. And so once I get the x coordinates, right, now I have x equals 2 or x equal negative 2. Then I could see that I'm going to have a set of ordered pairs. I'm going to have some ordered pairs with 2, and then some ordered pairs with negative 2. So it's kind of like a game changer to what we're used to. But in this case, we just know we're going to have 4 ordered pairs, and then 2 of them will have positive 2, and the second would be negative 2. So the next thing would be is to go ahead and solve for y. We eliminated y, so now we have to solve for y. So how we solve for y is pretty simple. Methods never change. So I'm just going to plug and chug x equals 2 and x equal negative 2 into one of the original equations. And therefore, I'll go ahead and pick the first one, simple enough to plug and chug. So x squared plus y squared equals 6. So let's start with x equals positive 2. So 2 squared plus y squared equals 6. So this means 4 plus y squared equals 6, and therefore y squared is equal to 2. This implies that y is equal to plus or minus the square root of 2. Now you'll see when we plug in x equal negative 2, it's actually this very exact similar case, except when I plug in negative 2 here, squared plus y squared, that's the only difference, because anything squared is going to still come out to be positive. So it's still going to come out as 4 plus y squared equals 6. Therefore, y squared equals 2. And then you can see that, oh, this is so similar. They're exactly the same. So this means that I have some sort of combination, right? I have y equal to the positive square root of 2, or y is equal to the negative square root of 2. And this is where the 4 points come in. So I would have 2 positive square root of 2, 2 negative square root of 2, negative 2 positive square root of 2, and negative 2 negative square root of 2. So if just being careful, like, so this is essentially where you have the x, the positive solution with the positive y solution. And here you have the x with the positive solution of x with the, and then with the negative solution of y. And then here's the negative solution of x with the positive solution of y, and these are both going to be the negative solutions. When entering these in My Open Math here, notice that they do identify which is which. Here, the first one, they want them both to be negative. So in this case, I would have a negative 2. And here I would have a negative square root 2. The negative solution of x, so negative 2, and then the positive solution of y, which is just a positive square root of 2. And then here's the positive solution to x with the negative solution to y. And then here is both positive, so 2 and then positive square root of 2. And then if you just submit, it's exactly what they expect.